Hi everybody, in this video we're going to start talking about something called proving products. Before we begin, there's a couple of things that we need to know. On this slide, you'll see that I have a picture of a proportion. I have it written two ways. This first way on the left has the proportion with two fractions separated with an equal sign, which is probably the way that you're most used to seeing a proportion written. A proportion can also be written using colons. So here we have two fractions. The fractions are just represented with colons in between, separated by an equal sign. Both of these are the same proportion. The terms in a proportion that are in the position of C and B are called the means. The terms in a proportion that are in the position of A and D are called the extremes. Once again, these are just the names for the terms in a proportion that are in these positions. If your proportion is written like this one on the right over here with the colons, you can tell the extremes are the terms that are farther away. Notice how A and D are on the outside. They're the outer terms. They're the far away terms. And B and C are the inner terms, and that's where the means are located. So once again, you can just remember the positions that the terms are in. If your numbers or your letters are in the position of A and D, we call them extremes. If they're in the position of B and C, we call them the means. Now that we got our vocabulary down, we are all ready to move forward. Oh, there's one more thing I forgot to mention. So in a proportion, we know that we can solve a proportion through cross multiplication. So when we cross multiply a proportion, what we're doing is we're multiplying together the extremes and the means. And since a proportion does have an equal sign in the middle, the product of the extremes always equals to the product of the means. Let me give you an example. If I have a proportion, I'm just going to make up a random proportion. I'm going to say 5 over 10 is equal to 2 over x. And once again, I just made this up off the top of my head. So 5 and x, because of the position that they're in, would be the extremes. And 2 and 10, because of the position that they're in, would be the means. So in order to solve this proportion, I would cross multiply. I would get 5 times x, multiplying the extremes together, 10 times 2, which is 20, multiplying the means together, and in between would be an equal sign because we're cross multiplying the terms in a proportion. So just remember, in a proportion, the product of the means equals the product of the extremes. That's what allows us to cross multiply. This is going to be very important for what we're doing today. Let's take a look at this example for a second. Notice that all this example is asking us to do right now is to prove that triangle BEC is similar to triangle DEA. Take a few seconds, pause the video, and think about how you might do that, and write out your two-column statement reason chart proving the two triangles similar. After that, we'll take it a step further. We know that after we prove two triangles similar, we can prove that the proportion involving the corresponding sides is also true. Let me just reveal over here the full two-column statement reason chart for proving that the two triangles are similar. This proof uses alternate interior angles, and it also uses vertical angles. Now, since we have already proven that triangle BEC and triangle DEA are similar, let's prove a proportion involving the corresponding sides. So I'll just take BE and DE. Those are two corresponding sides from each of the triangles. And I'll just also take EC and EA. That's another pair of corresponding sides from the two triangles. Adding on to the proof that we have, we know from in class that we can just add one more step in order to prove a proportion. And remember that our reason is always the same anytime we prove a proportion. If triangles are similar, then their corresponding sides are in proportion. Now we know that when we have a proportion, we can cross multiply because the product of the means is equal to the product of the extremes. So what happens here if I multiply the extremes together and I multiply the means together in this proportion? Well, I get BE times EA is equal to EC times DE. This is a product because we are multiplying together. This is justified because in a proportion, the product of the means equals the product of the extremes. Now, just like when we prove a proportion, anytime we prove a product, it's always going to be the same reason every time. So you can kind of just remember this reason anytime that you see you have to prove a product. In a proportion, the product of the means equals the product of the extremes. So whenever you need to prove a product, it's 3 steps. First, you're going to prove your triangle similar. Then you're going to prove the proportion involving the corresponding sides of the similar triangles. Once you have proven your proportion, you can cross multiply and prove your product because the product of the means is equal to the product of the extremes. Pause the video and try this example over here. What we are doing here is first proving a proportion. After we prove this proportion, we'll take it a step further and prove a product. Hopefully you got the chance to write out your 2-column statement reason chart. Just like the last proof, this proof also uses alternate interior angles and vertical angles to prove the two triangles similar to each other. Once you prove the two triangles similar, you can prove the you can prove the proportion that it's asking you to prove using the reason if triangles are similar, then their corresponding sides are in proportion. Now let's take it a step further and let's prove a product. Just like we did in the last example, if I multiply the extremes and the means together, I should get a product from this proportion. And once again, this is justified because we know when we have a proportion, we can cross multiply. And our reason that we're going to put in the proof is in a proportion, the product of the means equals the product of the extremes. Remember, this is what justifies the cross multiplication that we're able to do anytime we have a proportion. So let me write this out. Multiplying the extremes together, we have AE times CE, and that's equal to the product of the means, which is BE times ED. Let me write my reason. In a proportion, the product of the means equals the product of the extremes. And there we go. Once again, we have proven a product. Remember, the steps are as follows. First, prove the triangles that you are talking about similar. Once you have proven the triangle similar, you can prove a proportion involving the corresponding sides from the two triangles. And then finally, once you have proven your proportion, you can then prove a product through cross multiplication. And your justification for that cross multiplication is always the same every time. In a proportion, the product of the means equals the product of the extremes. Here we have another proof example. And notice that this proof is slightly different because right off the bat, it's asking us to prove a product involving multiplication. So to develop a plan, we're going to reason backwards by answering 3 questions. Number 1, we're going to think about what proportion produces the product that we're being asked to prove. So take a second and think about what proportion would give us this product when we cross multiply. If you said Km over Kd is equal to Lm over Lb, you would be correct. And just to double check ourselves, we can take our proportion and cross multiply. I do get Km times Lb is equal to Lm times Kd, which is exactly the product that we need to prove. So you can always verify that you do have the correct proportion by cross multiplying, and just make sure that you do get the product that you are actually trying to prove. So let me just get rid of that to avoid any confusion. So now that we know the proportion that we need to prove, the next question we need to ask ourselves is, based on the proportion that we need to prove, what pair of triangles do we need to prove similar? So Km is from this small triangle over here. Kd is also from the same triangle. So I know that we're going to be focusing on triangle KMD that I highlighted in red. Lm is from this bigger triangle over here, and so is LB. So that tells me the second triangle that we're going to be talking about is triangle LMB. So now I know which 2 triangles that I'm focusing on from the proportion, the 2 triangles that we need to prove similar in order to prove the proportion and then prove the product. Finally, we'll ask ourselves, how can we prove the 2 triangles that we're focusing on similar? Pause the video. Now that we know which triangles we're proving similar, what the proportion that we're proving is, and what the product is that we ultimately need to prove, work your way through the proof, write your 2-column statement reason chart. First, prove the 2 triangles similar, then prove your proportion, and then finally, you can prove the product. Here I have the full written up proof so you can check your work. Definitely make sure to pause the video so you can check your work. And I definitely forgot to mark my diagram, so I'm going to do that now so that you all can see it a lot clearer as well. You should always mark your diagram whenever you're approaching any question. But definitely pause the video. Take as much time as you need with this proof.